So I'm going to look at a differential equations problem. I encourage you to get out a pen and paper, see if you can work it out before I talk through it. But the question says a curve has the property that its gradient at any point is equal to 1/10 of the y-coordinate at that point. It also passes through the point 0, 10. Find the equation of the curve. So this is a hopefully pretty standard differential equation problem. I'm just going to have to use some of the properties we spoke about in some of the other videos. Hopefully you would be aware that you could set it up like this. So it says the curve is the property that its gradient at any point is equal to 1/10 of the y-coordinate. So you could say that dy dx equals y on 10. Okay, what we can do from here is we can exploit one of the properties of differential equations, which we spoke about, which is we can sort of treat them as fractions. So dy dx can be thought of as a fraction. And so we can flip both sides. So we can set dx dy equals 10 on y. Then from there, what we can do is we can actually integrate both sides with respect to y. So if we do that, it's going to look something like this. If we integrate everything with respect to y, I'm going to get dx, the integral of dx dy equals, all right, 10 can come out the front, and then we're going to be left with 1 on y dy. What we can do from here is, firstly, we can recognize that dy in the denominator and dy here cancel out. So we just get the integral of dx. So the integral of dx is just going to be x. So on the left-hand side, we get x. On the right-hand side, we get 10. All right, integral of 1 on y dy is the natural log of y plus the constant of integration c. Now, you're probably wondering, why isn't there a constant of integration on the other side? Well, there sort of is, but if I took a constant of integration here and one over here, I'd move one to the other side, and we would just get one constant of integration. So from here, what we can do is we can subtract c from both sides. So we take away c, so we get x minus c equals 10 log e of y. And then divide by 10, so we get x minus c on 10 equals a log e of y. Okay, to get y on its own, because we want to find out what the function is, to get y on its own, we're going to take e to the power of both sides. That's the reciprocal operation of the natural log, is to take the take the exponent, so e to the power of x minus c on 10. Okay, then what we're going to do is we're just going to break this up a little bit. So hopefully you know one of your properties of powers is that you can break this up. So this can become e to the x on 10 multiplied by e to the negative c on 10. So what you get is an application there of your power rule, because the numerators get added. The powers get added together, don't they? And then we know the initial conditions. We know that when x is 0, y is 10. So we get 10 equals, all right, 1. Because when x is 0, 0 divided by 10 is 0, and e to the power of 0 is 1. Okay, so 10 equals e to the negative c on 10. And then we get, we take the natural log of both sides. So log base e of 10 equals negative c on 10. And so c equals negative 10 log e of 10. So then we get this. We get y equals x plus 10 log e of 10 on 10, because we substitute c back in. And we get y equals x to the 10 multiplied by e to the 10 log e of 10 on 10. And the 10s cancel out here. So you're left with e to the log e of 10. The e and the natural log cancel out. So this whole thing is just 10. So your answer is y equals 10e to the x on 10. Now you're probably screaming at the screen. I'm kind of aware that I think there was a quicker way to do that. This is just how I did it as I was going along, sort of showing all the steps, but I feel like it's not the most efficient way. So maybe you're welcome to let me know how you could have done that a bit more quickly, but I definitely feel like I could have done that quicker. So in any case, it's good to sort of see in detail what's going on. If we were to sketch the curve now, this is what 10 e to the x on 10 looks like. And we want to verify that the gradient at any point is equal to 1/10 of the y-coordinate at that point. So what we can do is we can put in a tangent. First thing I just want to say is it does go through this coordinate, does go through 0, 10, so that's a tick. And now we can just have a look here. So this is the gradient. This black stuff here, this black dot tells us the y-coordinate at that point. So at the moment, the y-coordinate is 6.6, and you can see that the gradient is 0.66. So that sounds like it's 1/10 of it. So that sounds pretty good. If we move to another value, 4.04 is the y value at that point, and 0.4 is the gradient. So just a bit of rounding there, but you can see that they are 1/10 of one another. So this looks like a pretty good solution. So yeah, hopefully that makes sense and an interesting application of differential equations. So good luck with all your studies, and I'll see you soon.